Hello, welcome to my YouTube channel. This is Yameba Simple Understanding. So today we are going to solve question under shear force and bending moment diagram. So this is the question. Draw the shear force diagram and the bending moment diagram of the given beam. And this is the beam. This is the beam that we have to solve. Firstly, we are going to draw our free body diagram. So free body diagram. So this is our free body diagram. So for a pin support, it has two reactions, which is horizontal reaction and vertical reaction. So let's name it as this. The vertical reaction to be R A Y, and the horizontal reaction to be R A X. And the roller support has only one reaction, which is only the horizontal reaction. So only the vertical reaction. So we have let's name it as R B Y. Yes. So we have it. Okay. So let's draw our sign convention. So this is the sign convention that we are going to use. Let me draw it here. This is our sign convention. Our sign convention. So this is our sign convention. So forces at the vertical direction upwards should be positive, and forces at the vertical direction to the downwards direction to downwards will be negative, and forces at the horizontal direction to the right to be positive, and forces at the horizontal direction to the left should be also negative. Okay. And moment to the clockwise direction to be positive. Moment taken to the anti-clockwise direction should be negative. Should be negative. So this is it. This is the sign convention. Sign convention. So this is the sign convention that we are using. So let's write our equilibrium equation. So equilibrium equation should be sum of forces at the horizontal direction equal to 0. Sum of forces at the vertical direction should be equal to 0. Sum of moment about a point should be equal to 0. So first we are going to take sum of forces along the horizontal direction first. So sum of forces along the horizontal direction will be sigma F S equal to 0. So sum of forces along the horizontal direction, we have this reaction, this force, which is RAX. So going to get RAX should be equal to 0. And let's go to the next one. Sum of forces along the vertical direction, which we are going to get. So this one is equation 1. So equation 2. Let's go. Sum of forces along the vertical direction, which is sigma F of y should be equal to 0. So I'm going to get, means this one is sum of forces along the vertical direction. So sum of forces along the vertical direction will be this one, this force first, this one, you have this one, you have this one, this one. All are in the vertical direction. So you have R, R, you have R, E, Y, R, E, Y, sorry, R, E, Y. It is positive because it is going upwards, which is positive. And we have 5 kilonewtons. This reaction of forces, is going downwards, so it will be -5, because it is going downwards, and this one too will be -8. So we're going to get -8. And this reaction of force is going upwards, so it's positive, because any reaction of forces which are going upwards is positive. So we're going to get positive R, B, Y. Okay, should be equal to 0. So this equation 2. Sure. So that is equation 2. So let's go to the next one. Sum of forces, sum of moment about sum of moment of forces about a point. Sum of moment of forces about a point, which is sigma m, is equal to 0. So sigma m equal to 0. So we are going to get sum of moment of forces about a point. So we are going to take, so let's take A. Let's take point A. So we are standing at point A and we are taking the moment. So A, we will get this from A. We are going to take moment of forces. So we take this force. This force is going the direction, this arrow is going clockwise direction, because it's going like this. So it's going clockwise direction. So we take this one going clockwise direction. So take 5 kilonewtons times the distance to the point A. So 5 kilonewtons times the distance to point A. So we are going to get 5 times 2. Yeah, because 5 times the distance is 2. 5 times 2. So we are going to the next one. We're going to the next one. So 5 times 2, yes. We're going to the next one. The next one is 8. The next one will be this force. 8 times the distance to the point A. So 8 times 2 plus 2. So we are going to get 8, positive 8, because it's on the clockwise direction. 8 times 2 plus 2. So let's go to the next one. The next force is this one. So this one, it's going upwards. The arrow is pointing at upwards, which is going on the anti-clockwise direction. So it will be negative R, B, Y. Negative R, B, Y, because it's going anti-clockwise direction, times the distance. Distance is 2 plus 2 plus 2. So the distance from here to the point. So 2 plus 2 plus 2. So let's solve it. 2 plus 2 will be equal to 0. So let's solve. So we are solving. So 2 times 5 times 2 is 10. 8 times 4. Sorry. 8 times 4 will give you 32. So plus 32 and negative R, B, Y times 6. So this one will go here. The R, this one will this one will go here. So we are going to get positive 0. Here is 0. So positive r b y times 6. We're going to get 10 plus 32. So after this one have crossed the equal to sign, it changed from negative to positive. So let's write this one as 6 r b y 10 plus 32 will be 42. So let's divide both sides by 6. So 6 divided by 6. So 6 divided by 42 will be equal to r b y will be equal to 7 kilo Newton. So r b y is equal to 7. So since we know reaction by, we can substitute it into equation 2. So this is equation 2. So we can substitute it into equation 2 to get reaction ay. Okay. So this is equation 2. Equation 2 from here. See. So we are going to, since we know reaction by, we are going to substitute it into it. We are going to r a b y minus 5 minus 8 plus 7 plus 7 be equal to 0. So I'm going to get r a y, this one away. Okay. So this ones will go here. We'll cross the equal to sign. Okay, I'm coming. So if you so 5 negative 5 minus 8 plus 7 will be equal to negative 6. 0 r a y. Yeah. So this negative 6 will cross the equal to sign to be 6. So r a y going to be 6 kilo Newton. So that is it. So we know our reaction A and reaction B. So we know our reaction A and B. So reaction A is equal to 6 kilo Newton and reaction B is 7 kilo Newton. So reaction B is equal to 7 kilo Newton. So you can confirm to check if your answer is correct or wrong. So we are coming to confirm if our answer is correct or wrong. So the sum of forces at the So the sum of upward forces will be equal to the sum of downward forces. So this is the upward forces, which is 5 and 8, and this is the downward forces, which is reaction A and reaction B. So 6 and 7. So I'm going to get something like this. So reaction A B plus reaction A B Y should be equal to the upwards force, which is 5 and 8. So we're going to 5 plus 8. 5 plus 8. So you know reaction A is 6 and reaction B is 7. So 5 plus 8 is 13, and 7 plus 6 plus 7 2 is 13. So all are the same. The sum of upward forces is equal to the sum of downward forces. Sum of upward forces is equal to the sum of downward forces. So our answer is correct. So our answer is correct. That is it. Thank you.